Hello everyone, welcome back to your daily dose of science. My name is Haley, I'm with the Asheville Museum of Science, and I'm going to be your educator today. So what we're going to be talking about today is we're going to discuss a couple of really cool science concepts that lava lamps use to function. Those concepts are solubility, polarity, and density. And then after that, I'm going to show you guys how to make your own lava lamps at home using a few simple materials. But before we get down to the science, let me give you a fun fact about lava lamps. The biggest lava lamp ever made was 4 feet tall and contained 10 gallons of lava formula. So how does the traditional lava lamp actually work? Well, inside of the lava lamp, there are two separate substances. One of them is that waxy mixture that we typically think of as the lava inside of the lava lamp. And the other is that thinner liquid mixture that you see that it sits in. So you may think that these two substances are very different, but in fact, they have very similar densities. And density is the mass to volume ratio of a substance. So even though their densities are similar, they are insoluble in each other, meaning that they do not dissolve in one another. So when you turn on the lava lamp and apply heat, the waxy substance heats up. And as it heats up, the density begins to decrease, and it rises towards the top of the lava lamp. When it reaches the top, it begins to cool down, and the density increases again, and it sinks back towards the bottom. And this cycle repeats over and over again. So now that you understand how the traditional lava lamp works, I'm going to show you how to make your own at home. So what you're going to need for this little experiment is some vegetable oil, some water, some Alka-Seltzer tablets, some water-based food coloring, and a recyclable plastic bottle of your choice. So the first step of this experiment I have already completed. What you're going to do is you're going to fill your recycled plastic bottle 2/3 of the way with vegetable oil. And then the last third you are going to fill with water. So after you have done that, as you can see here, you're going to notice that there is a separation there between the vegetable oil and the water. So looking at this, we can infer that the water has a greater density than the oil, and that's why it has sunk to the bottom and the oil is sitting on top. But that is not the only scientific concept that is at play here. The other is polarity. So the vegetable oil is considered a nonpolar substance, which means that the electrons spend an equal amount of time circling each atom inside of the molecule, whereas water is a polar substance, meaning there is an electronegativity difference in which the electrons spend more time around one type of atom than the other inside of the molecule. And that is why you see that separation that you see when you pour the two together. So this last part of the experiment is the fun part. So the next thing that you're going to do is you're going to take some of your water-based food coloring. I'm going to use blue, but you can use whatever color you want. And you're just going to put a few drops into your bottle, just like that. So once you have done that, you are going to take about 1/4 of your Alka-Seltzer tablet and drop it in. But it's really going to depend on the size of your bottle. If you have a larger bottle, you might need about 1/2 of an Alka-Seltzer tablet. And then you drop that inside, and it sinks to the bottom. So look closely at what is happening inside of the bottle. So what is going on is the Alka-Seltzer tablet has sunk to the bottom with the water, and there's a chemical reaction between the Alka-Seltzer tablet and the water that is creating carbon dioxide, which is rising to the surface in these bubbles that you see here and sinking back to the bottom. Because carbon dioxide has a lighter density than that of the oil, it rises through the oil to the top. And it creates that awesome lava lamp effect that you see here.